Greetings! This is part 2 of our Korg DSS-1 restoration. In part 1 we unboxed it, went through various exercises to verify that it works, and ended up with determining that the instrument basically works, but there's a whole bunch of issues remaining that will need to be addressed. And that's what we're going to start on this time. You may notice that there's a bunch of dryer sheets in it, and that's because when opening this thing up it smells like a bar early in the morning. Adding the dryer sheet makes it smell like a bar in the early morning with dryer sheets in it. I'll leave it up to your imagination, but I think after a few days the smell will hopefully get less and it'll be less gross to work on this. But what we're going to deal with today is this board that was installed. Well, that was in it, and that was basically wedged between two pieces of cardboard and the top of the panel. Very professional job. Now, this is not a Korg accessory. This isn't even made by Korg. You can't really tell who made this, but it comes out of another piece of equipment. And my quick analysis of it yields that this is a function generator or a waveform generator. This is a telltale chip, which is an ICL 8038, which is just that, an analog waveform generator. Then there's an op amp and probably another op amp here, and that's this thing. The only connection to the original instrument it has is a power feed over here that feeds at 12 volts off the floppy disk connector. The rest of the wires coming off are all parts of the mod. This wire has the mystery plug, goes to the mystery plug there, and then these 3 sets of 4 wires each go to the panel, to these 2 buttons, and to the 2 LEDs. Now the way it doesn't work, it doesn't output anything. It's getting power, the fuse is good, but it's not really working. But the intent right now is not to do a full analysis, but basically I've determined that this is a parasite and it needs to be removed. I will remove it carefully with all the wires intact, or lots of photos and notes, so I know what was connected to where. But this has got to go for now, and maybe in a future episode we'll try to repair and analyze it on the bench. Removing the parasite actually felt really good. We don't need something on top of here supported by cardboard and impeding heat circulation here. But it's going to be possible to bench test this, because really all that needs to be done, here are all the bits and pieces that came out. All I got to do is hook up 12 volts to the power feed over here, and then it's just sitting on the bench. Hook the output to a scope and see what gives. Next we're going to have to make this read an actual disc with real samples on it, which I don't have any yet, and there's a choice of 2 ways to do this. The easiest choice is put a flash floppy into it. Since I've downloaded a few disk images already, and it's common belief, or the AI believes, that all of the original factory disks have been put into the public domain, so they're out there and available. And I got a few on this. The other option is using a utility like image disk and actually writing floppies. I'll leave that as a second alternative, because the flash floppy part should actually work pretty quickly. But a digression first. First of all, of course, we have these ugly holes here, and also the one in the back panel for the 1/4-inch jack, and those will need to get filled eventually. But I'm going to hold off on that until I actually diagnose the parasite board, and there's a very, very, very slight chance that it may want to go back in, and at that point we could just reuse all of those holes. But second of all, another issue I had was that the left output, audio output, was low in volume and distorted and crackly. So what I noticed was this wire here carries the left channel audio from the board that has the volume control to the output board here, but it was cut right where the red heat shrink is, and this was inserted. It's almost like they tried to tap into the left output with something and then change their mind, and this just connected it straight through. However, the connections were really bad. There were wire strands floating around, and one side of it wasn't even soldered. So I thought I had it. I removed the extra wire and just repaired the connection here, and that did absolutely nothing. No change, still crackling and distorted. Finally, I tracked it down. I mean, there isn't really much that can go wrong at this point, especially since the headphone output worked. The headphones worked fine on both channels, so the only thing that was kind of suspicious was there is an output low-high switch, which is sitting right here. And when I started sliding that back and forth and playing with it, the sound briefly fixed itself. So I had the problem. A few squirts of contact cleaner later, and working the switch back and forth solved the problem. So now I have two good outputs coming in the back, and we can continue. I disconnected the power and data cables from the internal drive, plugged it into the Gotek with flash floppy on it, and I have a few images on the USB stick, so let's load one of the factory discs that I was able to download. Can't see the display, so let me turn off this light here. It comes on and does I don't know what. So now we need to select that we want to load a program. And these buttons, yeah, they are bad. Okay, get system A, press enter. Are you sure? Yes. So it says wait a minute, and it's loading. It does say please wait a minute, and that's not a figure of speech. It takes quite some time to load a system, which is basically a sample and 32 patches using that sample. So it's doing its little thing, and now we shall see if it plays this correctly. It should be a piano sample. Well, it's completed. Wow, these buttons. Yeah, guess what we're going to do next. But yeah, so it's loaded. And what do we have? Loaded the sample and it sounds fine. Now keep in mind this is from 1987. The maximum sample rate on this is 33 kilohertz. It's 12-bit, not 16, 12-bit, and this thing only has 256K of 12-bit memory, which is not a whole lot, and the keyboard version wasn't easily upgradable, even though later on Korg came out with an expansion that lets you go up to a meg, and then there was a rack version of it, and on and on and on. Also, a private individual made an update that let you put up to 16 megabytes into it. But that is all irrelevant to me, because all I'm interested in is restoring it to its original condition and playing the original samples you got or you could buy when this was new. And we're at the point where that works now, and maybe we can address some other issues next. Panel board came out easy, and thankfully it was entirely connected with plugs. So I can put this on the bench, replace these 4 buttons, and have a look at data slider A to figure out why it is only going, electrically only going halfway. So it seems to be only letting you go from like 70 something to 127 rather than full range. I replaced all of the push button switches because they were very intermittent, making it a chore to do any sort of menu navigation. Won't show it in detail, but these 2 boards have all the switches. You can see the back end of them here. It's just a matter of removing the screws, taking the boards out, and desoldering all the existing switches and putting new ones in. They're commonly available, and it's made a big difference when navigating the menus here. While I was at it, I decided to add a little bit of customization, and what I did was I changed the LEDs. There are certain buttons that have associated LEDs to show that they're pressed, and I changed them from red to blue, and looks rather nice actually. But look at the buttons. A simple press. No more bouncy buttons, no more wondering whether you're doing something wrong or the button is just not working. Anyway, operation has become a lot easier on this. And it looks nice to boot. Next, I looked at some options for me to make real floppies, and after thinking about it, it doesn't really make a whole lot of sense to put the floppy drive back in here. I mean, for originality purposes, yes, but even I am hesitant in doing so, so I permanently installed the flash floppy in here, and it works great. I still got to do a lot of organizing of images I have, but I already tried. I put a image on there, and I had the instrument formatted, and it worked fine. So I have a bunch of I can just copy that. I have a bunch of blank images, and use those to store any work that I do on the synth. So for now, that part is solved. We can always return to and revisit the floppy issue if that's something I deem necessary, but not for now. We're good with that. But the next step is the display. I received a replacement display, which is LED backlit. The normal one seems to be easily readable, but it has a very limited angle of view because the backlight is out on it. So what you see here, this board over here supplies the EL backlight with, I measured 97 volts AC, but the backlight's gone. But we're going to have a look at the schematics, because there are some slight differences before putting this in, electrical differences, and there's a physical difference too, because this thing is higher than this one. So it mounts, let's see if I can show that to you, over these, on these standoffs over here. There's 4 of them, and I'm going to have to put a spacer in there as not to mash it against the little display window. One other point I'd like to make is this instrument was taken apart at some point in the past, and the reason, I mean, it was taken apart good because there are screws missing. There are a lot of wrong screws in there, and I guess somebody took it apart, did something to it, gave up, and shoved it into a corner. And then a long time after that, they kind of attempted to put it back together, but they had lost a bunch of the screws, I guess, and they just jammed in whatever they had and called it good. So for that, I'm going to have to remedy that, and I'll show you. But for now, let's look at some theory on the LCD before I just swap it in blindly and possibly blow it up. Let's have a look to see how the current LCD interfaces or is driven. Schematic you're looking at is basically the user interface CPU that handles the display, LEDs, buttons, and things like that. It is driven by an 8085, which is a bit surprising considering this came out in 1987, but I guess it does its job. The CPU drives an 8155 PIA, and the PIA in turn drives most of the LCD lines. They're standard. We have ground, power, control lines, contrast. Now you'll notice the contrast is not connected on the CPU board, and we will see why that is. And then we have 8 data lines, and that's pretty standard to do it that way. No surprises here. And now the difference comes in if we look at the schematic that shows how the LCD backlight is handled. And that happens over here. What we have is a voltage inverter that takes in 5 volts. This is an oscillator circuit. Creates, I don't know what the frequency is. I didn't measure it, but it inputs a square wave, 5 volts in amplitude, into the transformer. And on the other side of the transformer, we get an AC output. But that's, I measured 97 volts AC on that, which is the voltage, or it's in the neighborhood of the voltage that the EL backlight requires. We will obviously not need it, but as I mentioned before, there also is a pot on here that lets you adjust the contrast. And yeah, we're going to have to keep this board. I'll probably remove the transformer and whatever else is required to completely disable the inverter part, because one of the downsides of this is, and I'm surprised this doesn't do it yet, but when these inverters get old, they start making a squealing noise, and that's usually the transformer going bad. And it is annoying in any case, but especially on a musical instrument. So I'll disable this, but I'll put the board back in so we still have access to the contrast pot, which sticks out of the front panel actually. And let's go do the work and see what it looks like. We're done with the installation. I was very fortunate that the physical location of the mounting holes on the new LCD matched the old one exactly, but this one is a little higher because of the LED backlight, or fatter I should say. So I had to make a few revisions on how to space these screws, put spacers in these screws so it doesn't start bending out the window, the LCD protective window. But it went in. As I mentioned before, there were a lot of wrong screws on here. The LCD was only held in place by 2 screws. And some of the screws were difficult to remove because I guess they cross-threaded them using the wrong type of screws. These are all metric screws, mostly M4s and M3, and always make sure when you're taking something apart to put all the screws into several small baggies and label them so you can put them back to original. But we got this one to go back together, and now it's a good time to have a look and see what the display actually looks like. So here we are. And there it is. It looks very nice. It's readable from different angles. You don't have limited view. It still has a limited viewing angle, but not nearly as limited as on the old one with the backlight missing. And I need to go through all the menus and make sure they all show up correctly. But so far everything seems to show up. So I don't think there's going to be a problem with this. And I think it's a very worthwhile addition. That, along with all the new buttons, makes it much easier to navigate and actually do useful things on this instrument. Well, I think at this point it's a good time to stop this episode. And hopefully in episode 3, we'll tie together all loose ends and finish up this beauty.